Welcome to the July 9th OpenZFS production user call. We have Andrew, Stu, Gibran, Jan, and myself, Michael, so far. And actually, we have Antonig, who has a report. So the 2025 OpenZFS User and Developer Summit is coming along. Registration is open. People are registering. We've just landed another sponsor. I will have a lot more news on that. Jan Ever the Sleuth noticed that the PAM ZFS keys PAM module is severely underdocumented, and it appears that the FreeBSD installer as of late allows you to create an encrypted user home data set, but it's not super clear on how that might actually be. What phrase did I use? You say undocumented? I think ridiculously undocumented. That said, you may get an encrypted data set for a user that you can't really use, and heaven forbid you have SSH keys hiding in there. Andrew kindly looked at OmniOS R151054, and it does not appear to have that module. I did a quick look, and it seems that FreeBSD, at least 14.2 on a system I just hopped into, has the module hiding there. And I have not seen it myself, but apparently there is a spicy discussion on OpenZFS Slack about the fact that multipath on FreeBSD, which many of us will say can be frustrating, needs to be supported at the lower CAM level rather than where it's currently supported. Any thoughts on that? Jan, I think you made a noise.
Skipping over the rant because I too have been bitten by this.
Yes.
The design problem is that Geom doesn't know the difference between a path error and a medium error.
Oh,
So
interesting.
if you have a valid path to a damaged disk, which is honest enough to admit that it has a unrecoverable read error or write error, it will be treated the same as if you unplug a cable and you still have remaining paths. So what will just happen is the path the error was detected over will be marked as failed, and it will retry over one of the remaining paths. If no paths are left, it will just re-enable all paths and hope for the best. And try again and again, and yeah.
And
So in certain corner cases, like when Geom is tasting disks for partition data, if you have an unrecoverable read error in a GPT partition, for example,
yeah,
the tasting will deadlock your system because it will retry the read to the damaged sector forever, and the kernel will not
yeah.
even get to the path where it encounters any timeout or stuff, because there is no timeout on this stage of the boot process. So your system can effectively, if you have this kind of poisoned disk with a recognizable but partially unreadable GPT table, you have a poisoned disk which will stop the system from booting if you that through Geom multipath.
Okay. Quick question, just thinking pragmatically, should the OS try a G-part recovery on all disks just for safety
That's not
and
the
hygiene
issue here.
at boot time? Well, it wouldn't help.
No, not
No.
really. It would
Bummer.
at most fix this special corner case, but you could have the same with file system metadata or stuff like that.
Okay.
The problem is that the Geom module doesn't know if it was an error of the path the request went over or of the medium. Maybe it was possible to infer that, but Geom multipath doesn't do that.
Yeah.
And sometimes CAM code auto detect it and then maybe even present just one device to the next layer up. So if you have your worldwide node number or port number,
Yep.
why not automatically just report one device to Geom?
Oh, interesting. Well, so is that conversation taking place where it needs to take place and possibly
I
not
think
here?
it's not taking place anywhere right now.
Okay.
It's just like a decade-old bug reports which sometimes get in bump. Hey, I ran into the same problem.
Yeah. Well, if you have those handy, drop them in. But thank you for bringing that up, and I doubt if any of us has a quick and easy solution to that. And if I'm not mistaken, Antonik, you do not have audio support according to Zoom, so you'll have to do interpretive dance over video. We do not hear you, and according to Zoom, you do not have a microphone. Oh, I hear putt putt. Anyone?
I think that was Andrew heading in,
Ah.
making noises.
Antonig, can you hear us? We don't think you have audio. I will message you. Audio. Other topics while we allow Antonig time to sort out his technology.
I'm sorry, I'm having a minor crisis. I'll be back.
Take care. Godspeed with that. Bye. And small point of order, I will be traveling the next 2 weeks. And well, sometimes that makes it easier to attend a call. Sometimes it makes it harder. The campsite worked remarkably well and the connectivity was good. And Kitty really wants to be a part.
Remember to either talk to your provider ahead of time when you travel to Europe or just get a local SIM card.
That is true. I may indeed bring this here old Android phone that definitely takes that ancient thing called a SIM card because my newer wife's phone too, just don't have SIM card slots anymore. So there's that.
And get an eSIM.
Well, if it's E, does one get it, or you just punch in a number they give you, I guess?
Or you install an app which installs the eSIM.
Oh, is that a thing? Okay, cool.
Yeah, that is a thing.
Okay, Antonig, going once, going twice. Oh, 1 sec. Here we go. Yeah, I crashed it. Cool. Ah, yeah, I know. Okay, in the chat, he's having tech issues. I guess I could show the cat, which is typically more popular than any tech topic, but hopefully he's up and running soon. Okay, Kitty, just hold tight. Kitty's not complaining anymore, and I've got a little tail wag, so there's that. Gibran, did you work out your, I don't know, nifty alignment on Windows, zvols, and host compression and metadata and all the good things?
No, I didn't get to, but I did have I did do some benchmarking with a NVMe slog device.
Oh,
So
cool.
that's been quite nice.
Okay, great.
Yeah, maxing out 10 gigabit Ethernet
Oh,
on
great.
my NAS device, which is quite nice.
Yes, of course.
Over which protocol?
On NFS.
Okay.
Should be doable. By the way, if you're talking FreeBSD to FreeBSD and you have a fairly recent NIC, you can also make use of kernel TLS acceleration and run NFS over TLS connections.
I have not tried that. I will try that.
Is that well documented, Mr. Branco?
Yeah, I think I should have an in page on that.
Okay.
Rick wrote some introduction to the I think file systems mailing list.
Yeah.
I know that is not a good place for documentation to be hidden in a mailing list archive.
I see. Okay. He's back. He has a microphone. He's muted. Welcome, Antranig. We'll keep us posted, Gibran. That sounds all very cool. Oh. You want to take this creature? Take the creature. Antranig, you're unmuted. Welcome. Can you hear us?
Hello. Yes,
hello.
can you hear me?
So I guess if you're ready to go, just give a overview of your system and what remarkable things you did this last few hours on Discord with a audience of millions, I'm sure.
Sure. Do you want me to share my screen?
Sure.
Okay. Share.
No objection.
Share. Desktop 1. Share. Okay. I guess you can see my screen.
Yes,
So
it's very super microwave.
yeah, very super micro. So the machine that I have is this one called whatever this weird corporate name is, which is basically a 90 bay system for you, and it looks like this, very fancy. Those are all of the 90 disks. However, it's made of 2 compute nodes. There are 2 compute nodes inside of it, node 0 and node 1, which sit at the back of the system. There you go, node 0 and node 1, or rather the other way around for some reason. Node 0 is already configured on done. I'm currently connected to it over IPMI, which I assume I have a connection. Yes, I do. It has FreeBSD, obviously. And it has, here's the weird part that we had. So what happened is, if I did Guillaume disk list, let's do grep Toshiba, currently you're seeing 13 disks, but the bay inside of it has 26, and it's expected to see 13 disks. But the reason why we're seeing 13 disks is because I moved one of the UEFI devices, one of the PCI devices to PPT, so PCI pass-through. Otherwise, I would have seen all of the devices on both of the nodes.
Okay, that's kind of expected.
That's kind of expected, but that's not what I had in mind, right? Because what I had in mind is node 0 to be the production and node 1 to be the backup. So that was my end goal. So what I did is I did it over PCI pass-through, which I'm not sure if it's the right way to do or not. However, for the love of God, I couldn't find any configuration in the BIOS controller setting or in this fancy thingy here about giving each device, each node, its own set of disks.
So have you looked under multi-node?
Have I looked under multi-node? Yeah, it just tells me the nodes. Like it's like, hey, here's node 1, here's node 2. You are currently here.
If you look at the nodes,
and here as well.
So what I would assume is that both nodes see both sets of the full set of disks, but you want to use multiple host bus adapters to do so.
Okay.
Just for performance reasons, because you will have for 90 disks, 1 HBA isn't enough bandwidth and queue depth.
Yes.
So I assume there will be SAS expanders in there, and you probably want to go with 2 or 4 piles of 4 to each expander.
Does this help? There you
go. If we could see all of it, maybe. But the right legend of the stuff is hidden. Can you scroll to the right or resize your window? Oh wait, my error, my mistake. Sorry.
No.
Yeah. Okay. 6 hot. I just have the call participant overlay on top of that. It was my stupid mistake. So yeah. So you have 6 hot serviceable SAS expanders in there. So 90 divided by 6.
15.
15 for each expander. And if I remember correctly, SAS allows you to go up to 3 expanders deep in a chain, but you can build a tree.
Okay.
But but the depth of the tree, at least in 2001, was limited. I don't remember which of the limitations were dropped.
Okay.
But yeah, that can easily be done with SAS expanders within the topology. So do you have the SAS, what is it called, SES controller util or something command?
Yes, and I'm trying to jump to this machine. One sec. If I'm not mistaken, I should be able to do 1, 3, 2, 20, 280. Okay, that's fine.
So you should be able to do something like SAS util show as root.
So 821. Let's remove that. Yes. I don't even have a user. One sec. Like I just installed it today.
Oh, okay. Because I am curious here broadly, what's the question?
Not a question, but rather Jan wants to do an observation. I think
Show and tell.
See, the bad part about automation is that you forget what the value should be. Because you know automation, prohibit password. Wait, prohibit is not allowing? Yeah, prohibit is not allowing. Yes is allowing. Okay, that's fine. SSHD restart. Now we should be able to do this. Oh, sorry. Okay, good. So SAS util, is that what you wanted, Jan, if I'm not mistaken, right? I think we can do list. No, not list. Status. Now I see half. I used to see 1, 2, 3, 4, 5, 6. Now I see only
Can you
1,
do
2,
a
3.
show?
Yes.
That should give you the human friendly.
There you go. So these are my SSDs, which are used for the operating system.
Yeah, they're kind of detected via the theta to SAS mapping. And then you should see something with DA something.
And here we see the disks. These are the disks that they start.
Yeah.
Yeah. So I assume this is going to be, let's see, 13 plus 2, that's 15. And then at the top in this one, I have another 30. So totals to 45. Now, if I disable the PPT, or rather enable the PCI on the other SAS controller, then I see 2 more. Yeah.
2 more, or
sorry, 3 more. 3 more. 3 enclosures more. Yeah, 3 enclosures more.
Okay, so probably they hooked them up either lazy chained or with a fan out, so that each host bus adapter is connected to half of the disks, right?
Yeah.
Or disk slots. That's kind of fine. So if you boot both systems, do both systems see the disk? Because there are expanders with 2 upstream ports, so that you don't need disks with 2 upstream ports. Those exists too, but they're pricey.
Let's try.
And yeah, then just kind of safety net is the liveness check during import.
Of course, UEFI.
Restart, reboot, reset. And reset, right?
I just wanted the virtual keyboard, which I can't. There we go. Hopefully.
I think there's even a shortcut helper.
Really? Oh, yeah, that probably was. Okay.
Macro keys or something, they call it.
Hopefully it boots into USB, because there's a FreeBSD USB attached to it. But yeah, no, I haven't had a scenario where both are booted into FreeBSD yet. We finished installing
That should be possible, and while scary,
Yeah.
if anything of the isolation goes wrong, both systems should see all disks at the same time.
Both systems should see all disks. Wait, that's normal that both systems see.
Yes.
Okay.
Otherwise, there's already some kind of isolation mechanism in place.
Okay.
You're responsible for not force importing on both systems if you want your pool to live.
Okay. I am okay with that.
Recent-ish, like 5 years or so, ZFS and FreeBSD has this thing called double import protection, where it will, a system which implements it will kind of poke a certain location every few seconds, and the import will wait for it, and if it changes within the update rate, kind of a liveness check. If there's a system which has the pool imported, it will tell you, no, the I'm alive counter has increased. I'm not importing this unless you really force me to, because there's someone else writing to this pool.
Okay. That one is fine. This one is still invoking a boot menu. Okay. Yeah, that's good enough. Go. So we do have a lot of questions with these systems, specifically the setup. So for this one, we went with the following.
I have a crazy question for you.
Full status. Yeah, go on.
Do you have a non-transparent PCI Express bridge between the two nodes?
Non-transparent PCI.
Can you try KLD load?
Okay.
IF underscore NBT.
NBT.
If I remember correctly.
No,
let me check how it's called.
However, Jan, there is a UE0 USB Ethernet that connects both.
Wrong order.
That might be IPMI.
NTB, non-transparent bridge.
Okay.
You missed?
Okay.
You missed?
Nothing in here. D-message. Nope,
nothing specific. Okay, so they didn't do that. One way these systems are sometimes set up is to have a PCI Express connection between the two nodes. And on FreeBSD, you can use this kind of window into the other machine's memory as an Ethernet-like interface to just basically have the DMA engine mem copy Ethernet frames from one system to the other.
So here in the documentation at page, where is it? I think 51, if my memory serves correctly, which I haven't passed yet. They have the following: Mezzanine card installation, which apparently
is a form factor for extension cards.
Host 2 says 3616, hyperfor blah 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 blah, and then we have this.
Here it is, PCI NTB switch.
Yes.
And
an Ethernet controller for high availability.
Maybe that's an optional card.
Okay.
And you don't need it if you have good network cards. Then you can just use a crossover cable if you need high bandwidth between the two nodes. It's just a crazy way you can make anything which speaks Ethernet, which includes anything which speaks IP, use the PCI bus between the two systems without going through a real network.
TrueNAS uses that heavily, right or wrong?
It's not wrong. It's just an uncommon thing to do.
And here's the second.
And NVDIMS for slog, etc.
And if I do sesutil show on this one, I will see more disks. So I will see the first one.
It's running a bit warm.
Okay, this is the first one that I see.
Is it really running at 64 Celsius?
Apparently it is.
The controller or a drive? Those can be
or the air.
Very different things.
At the back of the chassis. That would be worrying.
This is not staged in a rack yet. Keep that in mind. This is like literally on the table right now.
Okay, and is the air coming out of it
Maybe not that
kind of an
well,
oven?
Huh.
yeah. And here at the bottom, those are the other disks that I would see, right?
Yep.
So in this machine, what
See,
I
it's
would
26 SCSI disks.
yeah, on this one, what I would do is I would disable the first PCIe, I assume. So I
Why do
don't
you want to disable the PCIe?
because I want to have 2 nodes with 45 disks each.
You really want to split the system.
Yes.
Okay. That's
But the
heavy-handed, but easy to do.
well, my current model is doing it over
I assumed you wanted a
cat.
giant pool over all disks,
Oh,
and
wait, we have a
then
terminal. I forgot.
I assumed you wanted your pool to span all the disks in the system, and then switch which of the controllers imports the pool.
Here's how I'm doing it now. This is on node 0. I'm disabling the PCIe of the other SAS controller. So on the other one, I would disable the first.
Yep.
And I
That would
assume,
split your
yeah,
system. And then you kind of could use defctl to undo that.
yes,
But
that's the but that I'm
why?
looking for. Why? Because I want 2 different systems. One of them is going to be on production. The other one is going to be only for backup. I see
Backup
no
in what
value.
regard? Failover
Okay,
backup or
so
sending the same
you
data to
paid
the
for
same
all the
disk?
fancy stuff and you want to treat it as 2 cheaper systems. Fine.
Yes.
Whoa.
Or if what you're suggesting is I can move all of the memory that I have to one system and
All
then
of the disk storage.
and then enable all of the PCIes on one system and
Yes.
then have 2 separate pools
Sure.
on one system instead of having
If you
one
have an
pool
all
per
spinning
system.
disks pool, I
Yeah.
assume you don't have any performance limitations on the CPU side.
Mm,
So yeah, you could do that, and then you could do host upgrades on one system. Fair enough. It's spinning Rust.
yeah. And my disks are, Toshiba spinning Rust. Yes. Here's another question, though. If I have 2 systems and I want to do an upgrade, I would do like export on one system and import on the other system
You could do that
simultaneously.
so that you have if you have 2 systems which are both configured to, I don't know, NFS export the pool,
Okay.
and you keep them in sync with something like Ansible to keep them reasonably in sync, let's say, yeah?
Mm-hmm.
So then you could intentionally fail over, kind of export the pool, halt both HBAs with defctl,
Okay.
and then have them unhide them with defctl in the other system, import them, and then you have, because you exported the pool, it is in a clean state, then you can quickly import the pool in the other system, use, I don't know, carp or just generic routing or whatever to make the IP address available again and then run it. Heck, if you make it an intentional shutdown, you could even copy the kind of log file. I forgot the name for NFS v4, the server log file over. So that clients could resume the logs when they reconnect to the new server. Otherwise, they kind of have to be, the logs have to be broken because they didn't get moved over.
That's what I'm saying. It adds more complication. I'd rather have my production. This is my backup.
Yeah, totally possible. You could have had it cheaper, but it would have taken 2 rack units more.
Yes. Is there an issue with doing it the PPT devs way?
Not really.
Because I'm worried, like, what if something goes wrong and the kernel doesn't read this for some reason, and then
Move it to the
it's
top of your loader conf,
okay.
and the zpool .cache file should tell the kernel which pools to import, so it doesn't auto import the wrong pools. So yeah, it should totally work. It's just a bit wasteful.
Okay.
You
Because
have
the other
basically half of your
because the other way is way more complicated, which is like doing carp with some kind of PCI connection, maybe over the UE0, to make sure that as soon as the other one is out, this one changes from PPT to the actual driver, which I think is like NPR or whatever, right? It does that, and then it imports the pool, and then I still have to handle NFS because it's running on production, right?
So
I need
the
to,
advantage
yeah.
of the more complicated way is if you have written the manual but scripted failover, you can keep the maintenance window to a few seconds.
I can keep the maintenance window to a few seconds.
So basically,
Another,
NFS fades over from one controller to the
Yeah.
other within a few seconds.
Mhm.
Clients don't even have time to yell at you because it suddenly starts working again before they picked up the phone.
Mhm.
At least that's the idea.
Here's
The
here's
NFS
another
client
here,
isn't
here
stupid.
here's another question. So currently, my current strategy for backup from and sorry, I lost Zoom. Where did you go? There we go. So my current strategy for backup is doing it over the network, right? I have a 40 gigabit switch where both of these nodes are connected to it, and doing ZFS send receive. All sounds great, but here's the question: would it make more sense if I do the backup over PCIe?
You
Would it
can
be
only do that
faster?
if you have this non-transparent bridge configured as a pseudo Ethernet interface. If you don't have that bridge kind of card in it there, or it's not configured like that, then no, you can't.
Wait. What if I take out the the PPT devs line?
No. Okay, that would be heavy-handed, as in export the pool on one system, import that on the other, then do a local send and receive.
Yeah.
Yeah, but that would imply downtime.
And then but I'm doing it on the backup system.
And the question is, what kind of backup is in the same chassis? It's like basically one bad PSU away from everything going up in smoke in the whole chassis.
Oh, I see.
So
What
what's the
are your
purpose of this
uptime
backup? Is it
expectations?
kind of a backup against administrative errors and fat fingers and stupid users? Yes, that kind of backup you can have. Is it a backup against, oh, I had a voltage spike in my transformer station down the road? No, it's not that kind of backup.
Would the local copy over PC, would the local replication send receive over PCIe be faster than?
Remains to be seen how well the.
Well, I guess at the end of the day, when I'm having this kind of a setup, my bottleneck is not going to be the network. My bottleneck is going to be like the speed of the disks.
The question is, how many network ports do you have? Your Ethernet contacts
two times 40 gigabit on each node.
Do you have top of rack switches which support multi-chassis link aggregation?
Yes.
Okay.
I have the Dell S6000, which
can do that. It doesn't matter which model. So you can use the full bandwidth if you use multiple connections.
Yeah, but I assume if I do send receive, my bottleneck is going to be the disk read and the disk write of the pool, not the network itself.
Depends.
Okay, good point.
The pure sequential read and write bandwidth of 20 disks. 200 megabytes a second times 20.
Mm, 200 times 20, that's 4,000.
Mm-hmm.
So that's
4
what,
gigabytes a
4
second.
gigabytes a second. Times 8, that's
You
32
have a 40
gigab.
gigabit, right? So
I have
it's
40
roughly
gigabit,
around the peak. It's around the peak bandwidth of 140 gig Ethernet.
Okay, got it.
Assuming that everything works perfectly, which it wouldn't.
Mm-hmm.
You will always have bottlenecks somewhere.
Okay, I have to think a bit about this. So for my production system, I don't have much of a questions because I'm going to be basically doing RAID 10s, right? It's going to be a pair, or rather a mirror, a mirror, a mirror, a mirror, a mirror. It's going to go all the way like that up to 40 disks.
Mm-hmm. Oh,
And
wait a second.
yeah. Yes, waiting.
There's one possible advantage to making both HBAs visible to both systems, and then at software kind of doing one disk from this expander one to the other, because then you make use of the queue depth and so on, and lane bandwidth of both expander chains.
Okay.
So that you may get better throughput, because then you can share bandwidth dynamically. It also means you could be your own noisy neighbor.
Mm-hmm.
But yeah, kind of going alternating. But just
Basically, instead of overloading a single.
Instead of splitting your system down the middle, you kind of interleave your pools on the disks. So both systems see both disks, and one gets the odd and one gets the even numbered disks.
Mm-hmm.
Make sure by comparing the serial numbers that they have the same order.
Mm-hmm.
Yeah.
That's a nice use case, yeah.
One quick point, are you absolutely sure your data doesn't need better than n+1 redundancy?
So that's a good question.
Nobody likes triple mirrors. Every bean counter on the planet hates them in every way, but they are the thing to do, unfortunately. Just saying.
I'm using them.
Yes, you are.
But
if a disk fails, you have 0 redundancy. Just saying.
Yep. You're 2 unrecoverable read errors away from total pool failure.
Bingo.
And odds are that the time that you notice will be when a disk fails.
Bingo. Murphy's Law.
Yeah.
Have a nice day.
To recover from your failed disk, every block on the remaining disk in the same mirror has to be readable. If you have one unrecoverable read error on the whole remaining drive, your pool is gone.
Less than optimal.
So if I use triple mirrors,
you'll be hated, but it's the thing to do, and your performance will be amazing.
Read performance.
Read performance amazing insofar as it balances reads, and it's like woohoo, go to town.
So you can think of the IO scheduler for reads as a work stealing queue. So every disk will try to get reads from the read queue it can serve. So if you have 3 copies of your disk, there are 3 read heads on 3 independent spindles which can serve that read request. Of course, write requests have to be written to all spindles in the mirror. But you get almost triple the read IOPS and thereby triple the read bandwidth as well.
What about write?
Write throughput is almost the same as a single disk, maybe slightly lower, because writes have to be written to every disk in a mirror. Otherwise, it wouldn't be a mirror anymore.
And the number of VDEVs wouldn't matter?
Well, you would create one mirror for 3 disks in that case.
In theory, your best case is the write performance of the slowest disk.
minus a little bit of scheduling overhead.
Until you hit a weird firmware that behaves differently, even though it's the same disk.
Exactly.
It's
That's
like,
kind of
Yeah,
shit.
saying they're identical is kind of optimistic.
Exactly.
In theory.
Optimistically identical. I'll add that to the quotations
They
here
are
too.
reported as the same model, at least.
Right, exactly.
And assuming you bought them in batch, there's a good chance they also run the same firmware version. Chance, not guarantee.
For the backup, again, 45 disks, what would you folks do where I need capacity and not performance? I was thinking of doing RAIDZ.
Yep, RAIDZ too.
RAIDZ2 or RAIDZ3, yeah.
Yeah, I was thinking of doing RAIDZ2 of 7 disks in 6 groups, if that makes
what I would
sense.
try to aim for is, if it works out, is to have a power of 2 of data disks in your RAIDZ. That is optimal for alignment and padding reasons, but if you have big blocks, it doesn't matter as much.
Well, what he said was 6, was a RAIDZ2 with 6 disks, so that would meet that requirement. I think that sounds reasonable.
I think I said wrong. I should have said an error. Wait, 7 disks in RAIDZ2 in group of 6. Sorry, in 6 groups, or the other way around, right? So
something else to watch out for.
Maybe I misheard.
Is if you have a pool of that many disks, plan for a spare or 2 in the pool. Because you don't want to run to the data center because a single disk failed. You
no,
just
I agree
want
with you. I agree with you. I mean, if you do the math,
the spare and remember the next time you're on site to replace it.
Yeah, because if you do the math of 6 times 7, that's 42. So I still have 3 disks that I would use for a hot spare. Does that make sense?
At 45 disks, you're also at the starting point where it's an idea to think about DRAID, but it costs you a lot of flexibility. You're kind of at that point.
I don't know how DRAID even works, so it's kind of...
So DRAID is a lot closer to traditional RAID than RAIDZ. The downside is that you can no longer do variable length stripes but the big advantage is that your RAID is truly striped off. Kind of think of it as having lots of virtual tiny partitions and then lots of RAIDZs across those. The advantages is that the spares already contribute I/O bandwidth and IOPS, because you're kind of reserving a fraction of the capacity on each disk. The nice thing is also that you can, if you have a not completely empty pool, do a resolver by just doing sequential read. And here the nice thing is, because the data is kind of sharded across all the disks, you're only asking, if you're replacing one disk, for 1 divided by the number of data disks, the amount of bandwidth from each disk. So pool performance doesn't noticeably degrade while resolvering. The downside is that resolvering doesn't do an implicit scrap, because you're doing a dumb block level recovery, not a logical recovery. So if you have a very empty pool, RAIDZ recovery would be fast. The real downside is that your DRAID is a monster VDEF, which is kind of the size of a JBOD. So you can't grow except by multiples of JBOD now.
And it's considered a virtual spare, for what it's worth. Go ahead.
I believe one of the other advantages with a DRAID is that your actual resilver time is faster, not just less
A lot.
loadable.
Yeah, it's like a virtual.
A lot, because it's for the
spread.
disk you're resilvering to, it's a sequential write.
Yeah.
For the other disk, it's a little bit of sequential reads. So all this can contribute to the resilvering process. So you're a lot faster to resilver, and you're not just punishing a single RAID-Z. Because the real problem is that normally if you're resilvering from a failed disk, that RAID-Z or mirror that disk failed in is now under really heavy, not purely sequential read load. So kind of your whole system slows down every access to that VDEV. Now queues behind all of the resilvering, which is why resilvering is by default tuned to be very throttled down, which means long rebuild times. At a certain size, you kind of have to assume that it's a normal occurrence and not an emergency, special case to be resilvering a disk, and then performance under resilvering becomes important to you. That's kind of what DRAID aims for. The downside is that its random I/O performance kind of sucks, which is why you normally have to pair with an S-log or maybe even a metadata special allocation device to get enjoyable random read performance. Streaming throughput is fine.
But if random read is not part of your workload,
for backup
then hey.
server or a big kind of streaming workload, DRAID is a reasonable choice if you have the scale to justify it. If you have just 3 or 4 RAID-Z VDEVs, yeah, basically, if you're fine with growing your pool by adding additional JBots, not additional RAID-Zs to an existing server, then it's an option. If you're at the point where you're grumbling that why haven't we had expanding a RAID-Z forever, then you're not the target group. So if you care about RAID-Z expansion because you want to grow by ones and twos, don't touch DRAID. It's not for you. You won't enjoy the experience. Because now you don't grow by adding an additional RAID-Z. You effectively grow by adding several RAID-Zs in one VDEV.
And between having a RAID-Z 2 of 7 disks in 6 groups or RAID-Z 2 of 6 disks in 7 groups, what are the implications there?
So for something like a backup server, you could say you have 3 spares, that leaves you N45 minus 3, and then you create a RAID-Z 3 of each of the remaining 14 disk groups. That won't give you much IOPS, but it will give you plenty of capacity and redundancy.
Using the shorter groups, so 6 disks and 7 groups, you end up using more disks for redundancy, so you're not going to have quite as much space. That's going to be the big difference, especially for your use case you're describing. That's really not that performance dependent.
So you suggest using disks of groups of 6 in 7 disks. No, math.
I mean, it's one of those things. It's not. I don't think it's a huge deal either way. I don't have strong opinions here.
Okay.
At least not for a backup server case. The advantage probably of going with six disk wide lengths of 7 is that you're going to have that alignment that Jan mentioned, because you're going to have 4 as a
and the other
multiple of
advantage
2.
is
Let him finish.
that you have more IOPS, the more VDEVs you have. But again, we're talking spinning disks. If you wanted IOPS, you've already picked the wrong technology.
Yeah,
You
exactly.
said backup, so
Well, yeah, but,
For
and we're talking
backups,
backups too.
For backup server, I would consider something like dedicating 3 disks to spares, because that's just how the math works out, and then building 14 wide RAIDZ 3 as
Wait.
3 VDEVs.
How much wide?
14 wide RAIDZ 3.
Oh,
Because
good.
you have
14
n minus 3 redundancy.
9.
14 times 3. Okay. I'm with you. One sec. What was it? RAIDZcalculator.com. Number of disk groups would be 3. Number of disks would be 14 in 20,000 GBs at the RAIDZ 3. So I'd have 660 terabytes. And since I don't care much about the performance.
And again, streaming throughput would be fine. The thing is, the more VDEVs you have to stripe over, the better your IOPS and bandwidth get. But the thing with RAIDZ is that it actually increases your kind of block size, but not your IOPS. So the wide RAIDZ will be faster for sequential streaming workloads.
Sorry, Jan, for 3 times 14, my write gain would be times 3 of the slowest disk, right? No.
A lot faster, because you have 3 RAIDZs, and each of them kind of has 11 times the block size of a single.
Yeah,
so you can write. No. So if you have a RAIDZ 3, you lose both the capacity and the bandwidth of 3 disks to parity in the optimal case, and all the non-parity disks in RAIDZ give you a larger effective block size for transfers.
Larger effect, okay.
Which means you can transfer the same number of blocks as to a single disk, like let's say 200 IOPS. Your Z3 will have the same number of IOPS, but each IOPS writes to all the data disks. So now
I see.
You get almost 11 times the throughput of a single disk per RAIDZ. So kind of you can have
33 times.
In theory, and you won't see that in real life, but in theory, you get the bandwidth of 3 times 11 disks.
Okay.
Oh, goodness.
What?
Someone has the
playing.
brown chatter on.
Yikes. Hello.
What's happening?
Is that playing over the stream? Stop.
Yeah, something playing.
Yeah, something is playing over the stream.
Go away.
Is it mine?
Away. No, it's me. Let me hit
Michael is sharing his YouTube obsession with us.
I suspect that's an advertisement.
Yes, and it decided this needed video. Okay, so continue. I'm going to step away for a sec. Godspeed.
Take your time. I'm thinking. I really want to do the triple mirror on the production. I need to ask management and tell them about the risks. And I think for the backup, I like the idea of 3 times 14, but I also really much like 6 times 7.
Antonek, there is no risk other than the cost with triple mirrors.
Okay, that's a fair point.
And that's not a risk, that's a surety. You will have 3 times the disk usage. The risk is with thinking that a lots of disk paired mirrors pool is safe. Because, oh, I have so much disk I could lose in the optimal case. In theory, you could lose one disk in every mirror and the pool would be there. But you could also lose two disks or one disk and one read error in its corresponding mirror pair, and then your pool is gone because you lost one VDEF. And you must not lose a whole VDEF. Losing a VDEF kills your pool.
To expand on what Jan is saying there, RAIDZ 3 is probably going to work out to be less of a risk, since you can lose 3 things in the same VDEV without it being a critical failure.
And if you have spares in the pool, on the moment the pool faults a device for either disappearing or having too many errors, it will automatically promote the spare and start rebuilding while you still have n-2 redundancy.
Okay.
Yeah.
So 3 times 14 with
So the really
RAIDZ 3
important part about
makes sense.
RAIDZ 2 and 3 is that you have redundancy while reserving. If you have just a mirror, while you're reserving, there's no redundancy.
Which
because you have a single point of failure.
Which I'm going to strongly recommend is having redundancy while you're rebuilding.
Yeah.
I think that's important.
Especially consider how long it will take to do a traditional reserver on a non-DRAID on a 22 terabyte disk, especially if the pool has filled up and has gotten a bit fragmented. Rebuilding can take days. There are knobs you can turn to make kind of set the pause between scheduling reservering operations to 0 milliseconds instead of 2, I think, or something, and make the schedule more per batch. So there are SysCDLs you can tune to make the reserving more aggressive. But yeah, these are knobs you can turn to quickly recover an emergency. It's a lot better to never make a single disk failure become an emergency. Just something where you'll get a report from your monitoring, say, okay, reserver in progress. I will
Okay, well,
add
you
to
sold
my...
me. You sold me on the 3 times 14. That's for sure. Now I'm trying to figure out
Alternatively,
about.
you could have more RAID Z2s for a bit more ARPs, but less efficient space utilization. So yeah. Do you know anything about your production server? What's it going to be used for?
One thing only. It's just going to be NFS connected to Linux compute. And the problem is that the data is, how do I call this? Diverse is the American term for it, I guess. It could be lots of small files. It could be a couple of like 3 files, which are 800 gig in size. So it depends on what project it is.
Okay.
So that's why I need to have like a golden balance, not on either ends of the extreme.
Yeah, I guess what you can do is to make it more pleasant to use is to have write optimized NVMe disks as your journal devices. That means that when NFS does a sync operation, it just is written to the intent log and then quickly persisted to stable storage so that the NFS server is allowed to report success, which makes clients happy because then the badly written user interfaces will not show a spinning fall of death or other equivalents to that. Well, that could become a problem if you want to move a pool over to the other system. If you really certainly want to partition the system, that's not a big issue, but you can't just magically move the NVMe flash you put on a little adapter board. If your SAS controllers aren't just SAS and SATA, but tri-mode, you could put the NVMe flash on them, and some of the more modern LSI controllers support NVMe. But I don't think it will work through the SAS expanders.
Jan, another one is that, so for the triple mirror, then I could have like 14 groups, right? Yeah. 14 groups of 3 mirrors. That would make the size, give or take, around 280 terabytes. So what would
14s?
Yeah, right? 14 times 3. What would
300.
be my 300? Okay. So, what would be my write gain?
Number of triple mirrors.
Number, so it would be 14 times. Okay, got it. 14 times.
Read would, in theory, give you all the disks.
Read would give me all the disks. Okay. And my current setup is also giving me all the disks, right?
What?
My current setup, which is
pairwise,
two-way mirrors. Yeah, two-way mirrors.
That gives you more mirrors, so better write performance at the cost of redundancy.
Okay.
Read performance is basically the same. Write performance is better with more mirrors, which you get because you have two-way instead of three-way mirrors. But what it means is that you're kind of living dangerously.
Okay. So 42 divided by 2 would be 21 group, right? So a group of 21, 2 disks. In that way, the size would be 450 terabytes. So, okay. I need to discuss this with management because they're going to say one of these things. They're going to say either, hey, we already have a backup machine, so if we have a problem on production, but I'm going to need to rebuild the whole pool from scratch, right?
To recover, yes.
Yeah. So like one disk failure and one read error, go and figure.
But you could argue that if you have frequent enough replications to another pool, the amount of changes you lose is fairly minimal, but you will take a significant downtime.
What do you mean?
Unless you have a second system, which you keep kind of, so what you could do is you could do a kind of higher redundancy storage to your backup server, and then have another server which exists only as a kind of lukewarm standby.
So technically,
would be replicated too.
So technically, let's say my production had one disk error and one read error. Great. Okay. What I can do.
So your pool is now in a faulted state.
Yes. What I can do is I export the backup pool. I import the PCIe to the production. And I import the backup pool.
The PCIe device, you would have to shut down the system and move it over physically.
No, I mean, you know, why physically?
Oh, that's what you move a PCIe device. Do you have a PCIe kind of switching engine in the chassis, which allows you to logically move a device from one to the other? PCIe device?
No. I mean, I changed it from PPT to SAS.
Oh, you're talking about your host bus
Controller,
adapter, not about
not
the,
NVMe.
not about any kind of journaling devices via
No,
NVMe. Okay,
No. So I do
fair
that.
enough.
I import it,
Mhm.
and now people would be using it slower because
Yes,
but
you
at least
now
they can
turned your
work.
backup into your
Prod.
prod. Yeah,
Okay.
everyone has a testing environment.
Of course. Uh,
Did you ever mention protocols in all of this? Is it NFS or SMB or
only NFS. We only use
WebDAV?
NFS.
I mean, what? Okay, thank
We
you.
only use NFS. Yeah. So so this would help me regarding at least temporary downtime, so I can tell people, hey, I'm gonna be remounting NFS read-only, so you don't, because this is the backup system. I'm gonna be mounting the NFS read-only while I'll rebuild the other pool, basically the production pool, and then I do the same operation the other way around. Does that make sense as a strategy? Jan, you are muted.
If you're on a shoestring budget and can live with people yelling at you while you rebuild, yes.
Okay. The other option is doing the triple mirror, which is group of 14 disks of 3. I mean, I like it. I have nothing against it. It's absolutely amazing, but I'm not sure.
You wouldn't want to use this kind of pool layout for an NFS server.
Which one?
The very wide RAIDZ.
Oh, yeah, of course, of
Yeah,
course. I
no.
mean, the 14 times 3 RAID-Z3 for NFS? No, absolutely not.
That's not going to
Absolutely
be
not.
fun to use as an NFS.
No, absolutely not. Okay, I'll talk with management about the group of trees. I like that. For the backup, I think the 3 times 14 RAID Z3 makes the most sense indeed, with the 3 hot spares. The only last question that I have left is I have 2 NVMe devices that I should probably use as slog or log. For better write speeds because I am using NFS. I guess I can like just make a namespace or a partition on the NVMe and then do mirrored log. Does that make sense?
As long as you don't try to mirror between namespaces on the same device, sure. Sorry, I saw a mailing thread where someone did that. Oh, bother split it up into 3.
Oh my god.
Yeah, and now your
I
controller is
can
fried
I
because
can easily see someone do that by accident,
I
actually.
think it was on some home blabbing subreddit.
That's very funny. Jan, is there
Not
advantage of
to a guy
using?
who lost his whole test
Yeah, right.
environment by cooking it in a passively cooled system. Turns out PCIe Gen 4 SSDs don't like to be put into a passively cooled system under your red nests of other cables
Yeah.
and then slowly cooked to death.
Jan, is there any advantage of using NVMe namespaces instead of partitions?
Not really.
Okay.
I guess I think not really from a performance point of view or stuff like that, but yeah, it's just. I think in theory you can configure different record sizes and stuff like this for different namespaces. But I don't know enough. I haven't tried it how it works in real.
And how
They
large
should
should I set
behave
my?
like other disks, such that you partition them, perhaps. They should behave like other disks, additional disks, so it's not like there's some mythical surprise there.
And how
Go
large
ahead.
should my log device be?
I think the rule of thumb is 5 seconds of write bandwidth at your desired throughput.
Okay, how about if I set it to like 128 gigs? Would it matter?
Fine, as an S-log. Divide
Yeah.
that by 5 seconds, and then you get the throughput you're aiming for, but having a bit more doesn't hurt. The other thing you can do is just leave a partition of intentionally reserved capacity to make the firmware happy when it comes to wear leveling.
Yeah.
If you do it aggressively enough, you can kind of undo a lot of overly optimistic
Because the
firmware.
NVMEs are 512. I can just make them partitions of 128s.
Yeah, that should make the wear leveling firmware very happy.
Okay, that's good. That's good to know. I don't think I have any more questions about this system. This is a way better system than the previous one that we had. Because the previous one was like, hey, we're short on money, but at least we have some money. Here are 12 disks and only 12 disks. Go figure something. And I had to do like RAIDZ 2 with 12 disks on NFS for production, and it's a nightmare, of course, performance-wise. So this one is like much better. I think I might be able to convince them regarding the group of the three-way mirrors of group of 14s. But the problem is starting with it. Like that's going to be the problem, right? So I'm currently at zpool list. With the two-way mirrors, I'm currently at 120 terabytes. How many disks do I have right now? 12. So if I do it with a 12 disk, that's what's 12 divided by 3, that's 4 stripe
If
mirror.
we're done with that,
it would go down to 80 terabytes, right? So like I would be losing a lot of capacity.
So if you ask management, as in you come as an applicant to them, you've kind of given the game away.
What?
I would say it would be a better idea to tell them, we have these requirements with what I've had so far. This is what I can give you.
Okay.
But of course, that depends on the reality in the organization you're trying to serve. But by kind of petitioning them to be allowed to do the right thing, you're setting yourself up as kind of responsible for their denial.
Yeah, I mean, I would tell them that obviously three-way mirror is 50% better. Actually, it's 100. No, yeah, it's 50% better.
The math is not that easy because you're kind of doing probability that so if you have pool out of two-way mirrors, if you have a disk failure, to repair the pool, you have to read every block on the remaining disk in the degraded mirror to copy that to the new disk, to the replacement disk. So if you have a single error on that remaining disk, just one, the pool will not recover. The whole pool will treat itself as faulted. Not degraded, but faulted. But if you have a single read error while rebuilding. If you have RAIDZ2, RAIDZ3, or triple mirrors, you still have redundancy during the rebuild, because if you have a freeware mirror and you have a read error on one of the two remaining disks, for the pool to fail, the same block on the other disk would also have to be defective.
Now I gotcha.
Or if you have a RAIDZ3 on the extreme end, you have a pool, you have triple parity. So if you lose a single disk, on the remaining disk, you would have to have 4 read errors in this RAID stripe. one you have from your failed disk, so you still have 3 more you can recover from. Sorry, 2 more you can recover from. So you would have to have for a single block to fail, in that block, 2 more disks would have to have an unrecoverable read error. Which means either a checksum error or just reporting that the block is unreadable.
Oh, here's a stupid question. Is there
There are
a
a few
RAID
truly
Z4?
stupid questions.
Too late, right? Is there a RAID Z4?
No. There's
Nope.
been discussion of arbitrary RAIDZ where you could do any number, but the math is ridiculously complicated and nobody wants
No, it's not.
that. You can write it. We have a
It's
volunteer.
easy to write. The generic case would be something like Reed-Solomon encoding.
There you go.
You go from, for this parity stuff, we have more efficient encoding in RAID Z1. It's basically just XOR. And then you go to, okay, let's treat our data as a linear equation system. And then we over-define a set of equations to switch with the data as the solution. And then you can generalize that and you end up with Reed-Solomon encoding. And modern CPUs with SSE 4.2, which is quite old, or newer, have the right instructions to make that fairly efficient. So you could have a generic forward error correction kind of VDEF. And that would be interesting because maybe you could, this is really spitballing, you're not ready to use design. But if you now, instead of this, use some kind of object storage as a backend where you have in theory, near infinite size namespace, now you could just increment the name counter every time you write, and then garbage collect by deleting old blocks, but not reusing the storage. Yeah, you get something which would be quite nice for running on top of the services cloud providers provide, like S3. So that you could have a file system which lives on an object store. But that's so far removed from what ZFS currently does. Yeah.
Anything else at this time?
To my knowledge, I have 20 days to play around with this thing, so yay.
Yay.
Cool. 1948 UTC. Anything else? Any humorous jokes? I threw in some potential quotations. Well, they are quotations, but who knows if they're t-shirt worthy. I will be traveling. Hopefully that works out better than ever. And I wish you all well. Who wants the honors? Antonig, you've been away. Let her rip.
Please like and subscribe. Thank you for watching.
Thank you. And please fall asleep to it so that we keep our numbers high.
And if you didn't, please tell us how.
Bingo. Take care, everyone. Bye.
Sorry for waking you up.